maybe maximum 10. 7문제에서 maximum 10문제인데 주로 10문제는 잘 안 내고 한 7, 7 or 8 or 9 maximum. Okay, today we have this week we have a today class and Wednesday, so it's enough time to finish chapter 3. So chapter 3, let's see, we are studying discrete probability distribution and the binomial distribution. Last class, binomial distribution is probability when x is a binomial distribution with a number of trial n and probability of success is p. Probability that number of success is x is n combination of n then success x, and probability p is a success probability, so p to the x and the 1 minus p is the probability of a fail. So this should be number is n minus x 이렇게 돼야 되지. So we have seen the example, and the probability of success, proportion of success. At the end of last class, the proportion, suppose x is a discrete binomial distribution n and p, and what happens if another variable, another random variable and y is x is divided by n, then this is called proportion of success. 이렇게 얘기하지. proportion of success. 성공 어떤 비율, 어떤 success의 비율 이렇게 얘기하지. Then we have seen that expectation is just p because proportion means proportion, ratio of success. No matter how many trial이 어떻게 몇 번 있든지 many trial 있는 경우에 success ratio는 expectation은 p가 될 거고 variance of this should be y. Variance of y should be n. p times 1 minus p divided by n 이렇게 되지. So expectation is just p. Variance of y is the proportion of success is the variance is p times 1 minus p divided by n 이렇게. So if n number of n is increased, then variance of a proportion of success decrease 이렇게 되겠지. We have in our text we have a graph. For example, proportion of n분의 x 이걸 생각해봐. 여기 number of trial이고 in our textbook page 159 there is a graph. For example, suppose x is tossing a coin. 늘 tossing 한다고 치자. tossing a coin. Then probability of success. For example, probability of head is just 1/2. 2분의 1이지. So try to toss a coin first time. The expectation of success is 1/2. 근데 are you sure that suppose you have toss first 10 tosses. Suppose you toss a coin 10 times, first 10 times. The expectation of a proportion of a success, proportion of head is 5 because probability of a success is 0.05, 0.5. But we are not sure that even first 10 times of a toss, sometimes we have 10 times fail. For example, 10 times we have tail이 나올 수도 있어. 뒷면이 10번 나올 수도 있다고 first. So at the beginning of a trial, expectation is one half가 되지만 이게 we don't know the proportion is a very variant. That means there are many changes of this expectation. But after and we have a multiple many trial, then the proportion becomes 0.5가 되겠지. So suppose the n is suppose the variance of this y. For example, 10 times. This is 20 times. This is 50 times. Suppose 100 times. Variance of y is there should be some number, a little large number, because first time of trial, for example, 2 times trial, 3 times trial, 4 times trial, head, we cannot have a head 할 수 있어. 우리가 헤드가 한 번도 없을 수도 있다고. Maybe first 5 times we have all fails. For example, all tails. 맞지? First 10 times we have some, maybe there is a very small chance that we have all tails. That means we fails all 10 times. But suppose we tried 100 times coin tossing 한다고 생각해보자. But what is the probability of that 100 times are fail? Very small. That means if tried many times, then the variance of y, proportion of y is very small. Up to 10 times variance, this variance is, for example, just an example, 10. After 20 times, variance is 5, reduced to 5. After 50 times, maybe variance is 1.5. After 100 times, the variance of y is maybe very small. And if n number goes to infinity, the variance becomes very close to 0가 되겠지. This is a proportion of success. So simply speaking, 간단하게 말해서, simply speaking, proportion, simply speaking, that if n number of trial increase many times, the expectation is p, and if the number of n increase, very large number, there is no variation. 변화가 없다. Variation means changes. Variation means the term of variation means a kind of a variation. But there is no variation. 여러분, 동전을 1000번 던지고 10,000번 던지면 그 전체 비율이 success 비율이 0.5. success rate이 just half 된다는 건, one half 된다는 건 알 수 있지. 여기까지가 밸런스고 3.2 section. Let's see geometric and negative binomial distribution. Definition: geometric distribution. Let's see another distribution called geometric distribution. Consider a sequence of independent Bernoulli trial, and constant success probability P. Let me read the definition of a geometric distribution. The binomial distribution is a distribution of a number of success occurring a fixed number of trial n. It is sometimes interesting to count instead of a number of trial, but so geometric distribution interest in the probability of x is x when this number is a number of first success. Suppose also probability p. This is a probability of success in Bernoulli trial. So first trial, the single trial, we have a probability p that the success. So success probability p, and in the geometric distribution, what is the probability that we have a first success in the x when x is x, when number of trial is x. That means one pair x minus 1 times we have to fail until there is a success at when x is x. 이 말이지. x times trial인데 x times trial인데 only success is at x. First trial, second trial, third trial, and x trial. And first trial is a fail. Second trial is also fail. Third trial is fail. Until when it is a success, only success is at the x time at this time when x is x. 여기 this is a geometric distribution. 이 전부 다 트라이얼이 전부 다 failure. First, second, third, all trial is fail, and only when x is x, only there is a single success. Only single success, that means we have only probability p is times 곱하기가 한 번, multiplication is only once, and except only this probability, this is a fail probability, should be how many times? x minus 1 times fail 이렇게 있어요. This is called geometric distribution. Each 하나하나의 each trial is this is a Bernoulli trial이다. 이거 Bernoulli trial. Actually, geometric distribution calculation, computation is very simple because there is only single success가 있어야 때문에 probability of success is multiplied by only once multiplication 되고 probability of fail should be multiplied by x minus 1 times 이렇게 multiplication 돼야 되지. 여기 probability that 이렇게 되는 것이 이게 geometric distribution. And geometric distribution expectation x is 1 divided by p, and variance of x is 1 minus p divided by p square. Sometimes in geometric distribution, there is a problem that asking what is the probability that the number of first number, this is a number of, in geometric distribution에서는 요 x number가 number of first success까지의 number이다. 이게 if what is the probability x is less or equal to x? This is in formula. This becomes 1 p times 1 minus p x minus 1 이렇게 된다. Actually, you can calculate this probability. If in textbook이 있는데, you can see also textbook. 요거는 summation probability x is I when I is 1 to x. This I should be 1 because there should be a single success 있어야 되기 때문에 I should be start from 1 to x, and this is summation 1 minus p I minus 1 times p. Let's use this formula. I is 1 to x. 그렇게 하면 이거는 p times 1 plus 1 minus p plus 1 minus p square plus and plus up to 1 minus p x minus 1 이렇게 되지? 요거는 p times what is this? In high school, do you remember this formula? 뭐 이렇게 등비수이라고 하나? It is called, in English, it is called geometric sequence. Geometric series, sequence or series. So it is this equation can be rewrite 어떻게 쓰면 1 minus p 1 minus p x divided by 1 minus p 이렇게 되죠. Then you can delete this and this, then this becomes 1 minus p x. Remember that there is a geometric series formula. If you have 1 plus r plus r square plus r cube plus r to the 4 plus until r to the x minus 1, then this becomes 1 minus r to the x divided by 1 minus r. 요거 알고 있지? 네. 여기서 this kind of geometric series, if x goes to the infinity, then this becomes 1 minus r to the 1 이렇게 되죠. But in case if 이런 경우, the magnitude of R should be less than 1. But in our case, we are handling probability. This number is always the magnitude less than 1. Because it's between 0 to 1, then always this magnitude of this R is less than 1이지. 1보다 작지. 그래서 geometric distribution. 이렇게. Okay, example of geometric distribution will be seen later. 나중에 보고. 이게 geometric distribution. Negative, let's see negative binomial distribution. There is a graph. Coin tossing 생각해보죠. Coin tossing. Then this is X, 1, 2, 3, 4, 5. This is the probability of first success is in X. is S라고 해야 되나? X is the first success. Because tossing a coin이기 때문에 probability of success is 0.5. So this is a first success in the first toss, then is a probability of 0.5. What is the probability that X is 2? So first success should be at the second trial. That means first trial this should be failed. Then that means 1 minus p times p. 1 minus p in p is the same. 이렇게 해서 4분의 1 이렇게 됐지. What is the probability that x is 3? Then that means when the first success, then for example, success is head of coin. The first success is at x is 3. That means first two trial should be failed. 되겠지? 그래서 1 minus p fail 2 times and success. 그래서 이렇게 이런 식으로 되겠지. This means that when tossing a coin, first success at the x is 5. That means 4 times of fail and single success. This is in this case, fail and success probability is the same. We can multiply the 0.5를 계속 multiplication 하면 된다. Okay, next distribution is called negative binomial distribution. So let's see the definition of negative binomial distribution. This is a more general version, general general distribution than geometric distribution. Geometric, in case the probability in negative binomial distribution, probability that x is x, this is a number of the definition in negative binomial distribution, this variable number of R's success. Negative binomial distribution is a more generalization of geometric distribution이다. more 일반화된 거야. generalization. So 이거는 x is the number of R's success다. In geometric distribution, this is R is if R is 1, this becomes a geometric distribution. Number of negative binomial distribution, x means the number of R's success in X's trial. X trials. X trial 했는데 X trial, each trial은 still in this negative binomial distribution, trial means this is a Bernoulli다. Bernoulli. So each trial은 Bernoulli trial이야. Bernoulli trial means only there is a success of A이고 success probability는 B인 거야. 그래서 probability X is there should be R's success가 있어야 된다. In X trial에서. Then how many fail 있어야 돼? How many fail? In X trial, X number of X trial, how many success? R success가 여기에 success고, how many fail? N minus R fail 있어야겠지? N minus R fail. So number of fail은 N minus R, number of success는 R이야. So in Bernoulli trial, the probability of fail N minus R times the probability of fail is 1 minus P is 2 N minus R 이렇게 있어야 되고 그 다음에 number of success R, that means the success probability should be multiplied R times 이렇게 되겠지. Another multiplication, there is another multiplication combination. This combination is x minus 1 combination to R 마이너스 1 이렇게 돼야 된다. combination X 마이너스 1 R 마이너스 1 이렇게 돼야 된다. This means what this means? Suppose there is a okay. Let's see this figure. This let's see. This is a trial X. First trial, second trial, third trial, fourth trial. 이렇게 갔지? X까지? So suppose we want R's trial. Number of success is R. Then number of success R should be happen when? 여기 있어야 돼. Suppose, okay, example. Suppose R is 3. Third success is 여기. Third success should be happen 언제? X에서 있어야 돼. So final trial, this is a final trial should be success란 말이야. Why? 네거티브 바이노미얼 디스트리뷰션에서 definition이 number of R's success가 in X R's exactly speaking 조금 영어 표현이 조금 틀렸네. Exactly speaking is this is a wrong expression. 틀렸다. R's success at number of R's success should be at X's trial이 있어야 되네. 요게 중요한 거다. 요게. This is important. 요거. R번째 success가 언제 X번째 있어야 돼. R's success should be at X's trial is. If R is 3, third success should be at X 있어야 돼. That means we don't care. 상관하잖아. 어떻게? Another two, there should be another two success가 여기에 이만큼 있겠지. 언제까지? X 마이너스 1까지. Another two success should be between 1 to X minus 1 trial 있겠지. So we don't care where is success from first trial to X minus 3 trial. So we don't care means there is a combination that X minus 1 trial, there is an X minus 1 trial, then there is a R, this 2 means R minus 1 success. Success can be anywhere. 어디 있어도 상관없지. For example, X is 5, R is 3. That means trial is at the fifth trial there should be R's success. That means the fifth trial there should be success. 1, 2, 3, 4, fifth success. So this is okay. And another way, there should be 2 success, and at the fifth trial, there should be success. Okay, this is also negative binomial distribution. 이렇게 되지? So we don't care. First 2 trial is anywhere up to X minus 1 trial이지. 그래서 the multiplication should be combination X minus 1 to X, Y, R minus 1. 이게 combination 있어야 되지. 그래서 this is a negative binomial distribution. 요거는 뭐지? 이렇게 what is the total number of this combination? This is a combination 4 to 2. 이렇게 되지. So first 2 trial. The total success is 3. First 2 success is anywhere in first trial. So this is x minus 1, this is r minus 1. Okay, expectation. In this case, negative binomial distribution expectation of x is r divided by p이고 variance of x는 r 1 minus p divided by p square 이렇게 돼 있네. 요거 뭐 이렇게 책에 나와 있지 않으니까 증명은 하지 않는데 there are many in chapter 3 there are many distribution and there are many formula. For example, expectation and variance. You don't need to memorize all formula. 모든 포뮬라를 외울 필요는 없다. There are many distributions and many formulas. If you need some formula in the exam, then I will give you the reference sheet를 주겠다. reference 참고 자료를 줄게. example 한번 볼까? 응?
여기 왼쪽 상단에 n-r 있는데 저 n이 x일까요?
잘못 교수님 잘못 쓴 x 마이너스 r n이 아니고 잘못 썼지? 여기 x 마이너스 r x minus r. It should be, this is x. The number of variance x minus r. n minus r이 아니고. Example in our textbook, example 25. Suppose you have a phone call to someone. Very simply, let me very simply explain this question, this problem. Suppose you have a phone call to someone and the probability of success is very low. This example says that this is success is only 0.1. Then the question, what is the probability that that first success is fifth call. So if question asks you that what is the probability that first success is fifth score, then what is this distribution? This is a geometric distribution. This is geometric distribution. It's very simple. Probability x is 5. That means this is a first success is fifth course, fifth trial. That means fail is 4 times and success is first the single time multiplication. Then this is 이렇게 하면 0.066. What is expectation? Variance. What is the probability that x is greater or equal to 15? This means that this is 1 minus the probability that x is less or equal to 14. Then this is 1 minus. You can solve this also, but you can remember the geometric series formula. This is 1 minus. This is 1 minus p to 14. This becomes 0.9 to the 14th. This is a very simple example. Another example is related to negative binomial distribution. negative binomial 한번 볼까? Example 12. Example 12 is related to a company hire이 뭐지? 고용하는 거지. hires 3 new workers. One to two. 어떤 회사가 3명의 새로운 신입 사원을 뽑으려고 해. A company wanted to hire 3 new workers. Probability that 0.6. Probability that when the company interview a person, then it is acceptable. Acceptable. Interview acceptable. Each interview acceptable. 이렇게 적죠. When company sees each interview and then the probability of success is 0.6, that means okay, a company okay. If someone comes to a company, then okay, this person is okay to hire this company 말이야. That means just simply speaking, this is a success, probability of success가 되겠지. Then question. Then what is question? What is the probability that x number of interviews. Number of interviews is 6 until the company found 3 newcomers. 컴퍼니가 3 workers. Interview. The number of interviews the company should have until the company find 3 new workers. 회사가 3명의 새로운 신입 사원을 찾을 때까지 몇 번을 인터뷰해야 되냐? How many times the company should see the interview until the company found 3 newcomers? That means this is a negative binomial distribution. And this 3 means this is R, the number of success. And third success should be happen in 6th trial 이렇게 있어야 되죠. 그래서 combination 있고 1 minus P fail the x minus 3 that means x is 6고 여기 이렇게 되겠지. x minus 3r and 0.6 times 3 success probability should be 3 times. There is a combination x minus 1 to 2 combination. 5 trial, 5 interview, there should be 2 success가 있어야 되지. 5 interview. 그래서 이렇게 계산하면 되겠다. Game of chance. Game of chance. A die is thrown. 주사위 던지는 문제. Number of thrown made until 6 is obtained. 이렇게 number of thrown, number of throws until 여기 뭐라고 돼 있지? 라고 돼 있지? The 6 means that first success. 6 is obtained. This is a success. First success happen 될 때까지의 number of throws. That means this is very simply geometric distribution. Yeah, this geometric distribution. So x when x is x is 7. 특별한 건 없네. Expectation of x is 1 over p. This is 6가 되겠고. In our textbook, what is the probability that x is larger or equal to 7? This is 1 minus probability. X is small n equal to 6. 요거는 1 마이너스 fail times 6 이렇게 해서 this is 0.335. 맞나? Any questions? So 이렇게 생각합니다. Main difference between geometric distribution and negative binomial distribution is that geometric distribution은 first success happens X trial이고 negative binomial distribution은 R success가 happen at X trial이다. So when R is 1일 때는 그게 geometric distribution이죠. 그래서 negative binomial distribution이 generalization of geometric distribution이라고 생각하면 된다. Let's see next. Okay, next section. Any question? Can I continue? 계속. Hypergeometric distribution. Hypergeometric distribution은 definition of hypergeometric distribution은 약간 컴플렉스해, 약간 복잡해. So let's see just the definition, then I will continue next section. A little complex. So So first, let's see again the binomial distribution n times trial and the success rate is P. Binomial distribution. Probability of x when x is a binomial distribution, the success when what is the probability of the number of success x is n combination x, probability p times of success 1 minus p fail. This means that 이렇게 보자. Suppose this is a box, and there is a success probability. Suppose there is a 이렇게 생각해요. Box. You choose something from box. For example, you choose a defective chip in box. What is the probability? So this is a success probability. So you get n trial. And this you have n trials. And the x success. This is a binomial distribution이지. 또 P 요거는 P는 베르누이. When you have a single trial, nth trial 했는데 single trial은 베르누이 트라이얼이다. Suppose you have a box. You have a x0, x1 success. You have another box. Okay, you have another box containing a defective chip. Defective chip 있어. So you have a x2 success를 했어. Another box. You have a x3 success. Another box. You have a x4 success. And this success rate is all the same. 이렇게 되지. And 이럴 때 you have this result, this variable x, this is a 이럴 때 this is a binomial distribution이 되는 거다. 이렇게. 토탈 넘버는 여기 토탈 넘버는 토탈 트라이얼은 n이다. 여기도 nth 트라이얼 있고 여기도 nth 트라이얼 이렇게 있는 거야. That means, suppose this you have one student, A student has take n number of chips. Then x1 number is defective. The student B take n number of chips. Then x2 number is defective. Student C get a box and n chips and the number of success is x3. Then is this experiment is 요거 independent이야 dependent? Independent. 뭐 이런 거 똑같아. Another example. A student flipped 100 times toss coin. 이렇게 할 수 있지? 그러면 what is the head? Number of head x1. Another student A, student B, student C, student D. 100 toss. This is a trial. N. Success x2, success x3, success x4. This is not variable이다. This is value지, result지, experimental result. This is value. This is also value. This is value. This is value. But this is all different지. So this is a random variable x가 되는 거고 이게 binomial distribution and p 이렇게 되는 거지. 그리고 and this each student's experiment는 서로 independent, all independent. But in case sometimes, very sometimes, suppose there are probability that success is p and 1 minus p fail in a 박스가 생겨야 되고. 박스에서 take n trial 했어. n trial. And success is x1. And then next experiment. The total number is, suppose here total number of chip. For example, in our example, what is the total number of chips? Is 500 있지? 500 chip 있지? Total number is n이라고 하자. Total number of, for example, chips. This is a trial. This is a success. But in the second experiment, total number is n is you already extract 요거 take 했기 때문에 take out 했기 때문에 total number is reduced n minus n 이렇게 된 경우. Another n trial and success rate, success number of success. And another experiment. This is a first experiment, second experiment. This is a third experiment. And the total number is n minus n square. 이렇게 됐지? 그러면 you take a student C has a trial, nth trial 할 거고, and the number of success is x3. In this case는 이렇게 서로 this experiment, each experiment dependent 돼버리죠. Dependent. 우리 그거 하는 것처럼 when you study event like taking the card game without replacement 하면 어떻게 돼? Take 1/5 from out of 52 card, I take one card and next person take another card. The probability is dependent가 되지. So dependent. 그런 문제가 되겠다, 그렇지? 그래서 우리를 single experiment, let's define the hypergeometric distribution. Single experiment에서 n is n는 total items. total items. And R number of success, number of defective chip. Defective means success라 이 말이야. Then what is a probability? What is the Bernoulli trial? What is the probability of Bernoulli trial? Bernoulli trial probability is R divided by N 이렇게 되겠죠. 요거는 싱글 테이크 when you take a single chip 할 때 success rate, success probability가 n분의 r이란 말이야. R divided by n. Probability of x is x. R combination R combination x times n minus r combination n minus x divided by n 이렇게 된다. This is called hyper geometric distribution. The formula is very complex. 여기 n은 뭐냐면 what is this n? This is a number of trials가 되겠다. 뭘 어떻게? Without replacement. example. Let's solve the one example of hypergeometric distribution, and let's finish today's class. Example 17. In a box, there is a 16 milk container. That means this is N, large N. Underweight container 6가 있다고 되어 있네. 6 underweight. That means this is R. What is the distribution of a number of underweight? The inspector how many? 5 컨테이너를 랜덤하게 컨테이너를 픽했다고 했을 때 probability that X is, that means 5 containers choose randomly. That means this is a trial N. So probability, for example, 2, if you calculate this becomes, if you use this formula, R is 6. The number of success 2, and the N minus R 10, and the N minus X 3 divided by total number N, number of trial 5. Then this becomes 0.412. Next class on Wednesday, we will continue section 3.4 Poisson distribution. Okay, see you Wednesday.